Okay, here we have a graph. Now, what I want to do is I want to see what happens to a smooth curve through these 3 points if I move the graph in various ways, very similar to an assignment you might well have encountered recently. So I'm going to draw a smooth curve through these graphs. Now, a smooth curve doesn't go this way. It'd be jagged. It'd have a point here. If it ran into you, it'd be uncomfortable. Okay, we want a nice smooth curve. Now, if it's moving fast enough to run into you, it's going to bludgeon you, but it's probably not going to try to penetrate. Okay, might bruise your ribs, won't break them. Okay, well, I'm going to draw my curve like this. It's pretty inconvenient to try to draw a curve that goes smoothly through this point down to here. Okay, I could loop way up here and then come down like this and so forth. Loop up, or I could maybe go through here and here and then turn smoothly this way. And I think I'm going to do that just because if I do it this way, I'm going to have to go up a little higher. I don't have that much room on my graph. So I'm going to come up like so, come through here, start turning, and then decrease rather quickly. Okay. I don't have a sharp point here, but it's a pretty quick turn. And there are many ways I could draw the graph. I mean, I could draw a graph that comes down here, up through here, down through here, up here, oscillating back and forth. Plenty of ways I can draw a smooth curve, but this is one of the more direct ways. So let's just say here's our curve. Okay, so might be a function, graph of function y equals f of x. Now what we want to do is move our original 3 points up 3 units. How are we going to do that? Well, we got to figure out how far 3 units is. Well, it's this far. So if I move this point up 3 units, I'm going to end up here, here. I move this point up 3 units, I'm going to end up here. I move this point up 3 units, I'm going to end up somewhere around here. Okay, I'm going to do that. And just to be helpful, I'm going to say, okay, let's just draw a little arrow here representing 3 units on the y-axis. So I can use this arrow, come over here, and I can up 3 units, okay? You could even draw the arrow here, that's not necessarily a bad idea. Alternatively, I could estimate the coordinates of these points. Okay, well, let's just go ahead and estimate some coordinates. This is 8, this is 7, that'd be about 7.2. And this is 16, this is 12. That's about halfway, but a little closer to that way. So I'm just going to make a ballpark estimate. Say this point, let's say this point is negative 13.8, 7.2. Then what should the coordinates of this point be? If I raise this point up 3 units, you would hope it would be negative 13.8, 10.2. Because we move up, the y coordinate is going to increase by 3. 7.2 and 3 is 10.2. I don't know how consistent that is with the way the graph is drawn. Looks like it comes out about 10. Okay. So if I estimate it, it's about 10, still 13.8 because it's vertically above this vertical line. Let's say this should be negative 13.2, 10.2. Well, where should this point be? I'm a little high there, but it looks like the coordinate here is about 12.5, and the coordinate down here looks pretty much like maybe negative 3. So maybe this is negative 3, 12.5. Now, if I raise that 3 units, it's going to increase the y coordinate by 3. And 12.5 and 3 is 15.5. So 15.5 is about here. I'm going to say, okay, well, this ought to be negative 3, 15.5. And then this point. Again, but let's see how that negative 3, 15.5 works. This is 3. Yeah, looks like I moved up a little further than this. My scale isn't real consistent. Okay, okay. This point appears to be about, let's do a little subdividing. See if this is 4 and this is 8, halfway between is 6, then halfway here is 7. So it looks like about 6.7. And the y coordinate, I'm going to say, let's see, here's negative 6, here's negative 5, here's negative 7. Not very good. Then I'm going to say it's negative 4.2. Okay, if I want to raise this point 3 units, then well, here's negative 2. Here's negative 1. Negative 4.2 and 3 is negative 1.2. So that my point would be about here. Okay. Now I'm doing this graph in yellow and I accidentally used the orange here. So let me at least make it look halfway yellow. And now I've got 3 points, and the shape of those 3 points is the same as the shape of these 3 points if I've graphed it halfway decently. So now I can sketch my graph. And here's my graph of f of x raised 3 units. Now I'm going to use a different word than raised. I can say vertically shifted 3 units. Okay, now I'm going to move every point of my original graph to the right. And I want to move it pretty far to the right. Where would be a good place for it? Okay, I'm going to move it. Okay, so we moved up 3 units. Now I'm going to move to the right. I'm going to move 16 units to the right. And make myself a purple graph. Okay, so 16 units is this far. So if I move this far, I should end up about here. Of course, we can use our estimates of the coordinates. Negative 13.8 and 16, if you do it, is 2.2. 2.2 should be about here. Here's 2. 2.2 be a little bit to the right. And of course, the y-coordinate is still going to be 7.2. So that now this point is going to move to here. That'll be negative 13.8, 7.2. So let's see, I'll just draw a purple arrow across the lines of the previous two graphs. And then I would take this point, 312.5, and it's negative 312.5, obviously. And move it 16 units to the right to get to 13 and 12.5. So if I move to 13, 12 is here, 14 is here, 13 is here, of course there's 15. Might as well put it in so it doesn't get its feelings hurt. Okay, so I'm going to take this point and I'm going to move it 16 units over until the x-coordinate is 13. Not sure how well I'm doing that. Got a bad perspective, not too bad. Okay. And I've got to move this guy over 13 units, 16 units. Now, I don't have coordinates that go that far. It looks like its coordinate here is 6.7. I had 16, that gets me up to 22.7. If I extend this graph 8 more units to the right, that's going to have to go through about here. So let's see, this would be about 24. And halfway between 16 and 24 is 20. Halfway between 20 and 24 is 22. And I want 22.7, so I guess I'll put 23 there. And 22.7 would be about here. So this point needs to move all the way over here till the x-coordinate is about 22.7. And I would get this point. Okay, so this point would be -22.7, -4.2. This point would be 12.5. And now I can sketch a curve that behaves like these curves, but for these 3 points. And so I can do that. And there we have it. So there's my curve, there's my curve, there's my curve. Now I can do one more thing. I think I've got room to do this, so let's go ahead. Now I want to move every point twice as close to the x-axis. Specify, we want to do that vertically in the vertical direction. Okay, well, how far is this point from the x-axis? Well, it's 7.2 units from the x-axis. So if I move it twice as close, it's going to be half that, or 3.6. Come up here and find 3.6. If I move it vertically, its x-coordinate doesn't change. So this point would be negative 13.8, 3.6. This point, moving twice as close, how far is it? 12.5. So what we want to do, half of that, well, that's 12.5. Half of that is 6.25. 4, 5, 6, 7. I divide 7 in half and then divide that lower half in half. Then I get about 6.25. Come over here. And I get this point, which is approximately negative 3, 6.25. Move this point twice as close. Well, that's going to be, it's 4.2 units from the x-axis. We're going to move it closer to the x-axis. And we're going to keep it on the same side of the curve. We're not going to move it on the other side. Unless we happen to say that's what we want to do. But half of 4.2 is 2.1. 2.1 would be about here. I didn't do a great job of scaling this thing. But here we would have then the point 6.7, negative 2.1. And now we have 3 points, and we can draw a curve for those 3 points, following the same idea as this curve. But if we do this, I got to get down to there. The curve is going to look more like this. It's going to be flatter than either of these curves. These curves all have the same shape. So should have another color here. I don't confuse my labeling. Okay. So we have 3 curves here, same shape. And then we have a 4th curve. Like I said, that's vertically squashed down. Okay, take the shape of any of these curves. If I could grab this curve and move it over here, it should fit right on top of this one. Now it won't because I hand drew it, but it'll be close. Okay, or this curve, if I just lift it up, should be this one. Or any of these 2 curves, fold over here, ought to match this one. Well, it's really, really important to understand moving graphs around because we do that with our basic functions. We move them around, we squash them down or we stretch them out. We can squash them down vertically or stretch them out vertically. We can squash them down horizontally or stretch them out horizontally. And we can make those graphs into a wide range of functions that have profound applications in the real world. And that's really where we're heading with this. So there we have it.